I'm happy to talk my presentation in RubyConf Australia. So today's topic is a long journey of Ruby standard library and Ruby core packages. So we start to explore our daily stuff is or the Ruby programming language. So it's my introduction. So I'm Hiroshi Shibata. Please call me Hiroshi. So I'm an open source software developer at Endpot. So I am a proud member of the Ruby core team and the Ruby Gems and the Bundler team. So my work is develop and maintain the Ruby programming language and the Ruby ecosystem and its infrastructure of Ruby. Thank you for using Ruby and write a Ruby Gems and Bundler every day. So I've journeyed from Japan to be present at the RubyConf Australia today. So you know Japan is the birthplace of Ruby language. So I'm happy to attend Australia today. So let me introduce you to my company named Endpot. So Endpot provides our SaaS provider that is a platform for the construction industry. Our service is built with Ruby and Rails or other languages. So sorry, I have only available Japanese images. So we are developing a lot of products to cover all people whether in the office or outside stuff. Our goal is to make them happy through the digitalization used by Endpot. So in Japan, our construction industry is over the $1,500,000,000 Australian dollar market size. So we need more speed to develop product by Ruby and Rails. So Endpot is a strong supporter of the Ruby ecosystem because Endpot is hiring me as a full-time open source developer. Now today's talk, so let's begin by introducing the first topic, running history of standard libraries. So at first, so we need to look Ruby's require again, This is the classification of Ruby class and libraries. So at first, so we have an embedded class and standard libraries. So we don't need to require to use embedded class like a time or string or hash or something. So in the other hand, a standard library needs to call require method. And we can categorize the standard library to pure Ruby library and C extension library. You may need to load C extension library for external library like libyaml or libsSL provided by Linux distribution. So you need to build a C extension or something. So require is the most famous method which load additional Ruby code into your Ruby context. So if you wish to use RSS, so it can be easily loaded like this example. Require is a method returning true if you can load RSS, and false if you cannot, or raise a load error exception. Require will search from the load path, like your Ruby installation paths or gem home or something. So additionally, require can load C extensions such as .so in Linux or .bundle in a macOS platform, .drl in a Windows platform. And require will fallback these extensions automatically. So if you load big decimal.so in a Mac OS platform, so Ruby's require load.bundle too. So finally, so we have a require relative. So if you need to only the current path, like Rails root, so we have a require relative. So require relative will not search from the load path, only the current path. So this is illustrated how Ruby have a standard libraries themselves. So Ruby 1.8 has over 113 libraries. So this number is most large number is Ruby history ever. So in Ruby 3.3 that is released at the Christmas Day of 2023 in the last year. So that number is decreased. Its number is about 18.5. So what happened after the Ruby 1.8? So today I tried to introduce this. So it's time to come our Ruby gems. So how load Ruby code from the outside from the Ruby core packages or your Ruby installation paths. So in modern programming language, so we don't need to write generic algorithm and generic data structure with the standard libraries. So in past, Ruby have a Ruby application archive for this. This is not available today, so this is a web archive. So Ruby programmer uploaded your library or your hobby tool into RAA, or Ruby application archive. And you can download this archive and extract and install your Ruby installation paths. So how use these libraries from the RAA? So you need to run a Ruby script named like a setup RB for installation then. And surprisingly, setup RB will install extra library into the same place of Ruby installation paths. So you always need to run your sudo command or root account. In past, so Ruby fuzz is alternative of RAA. So .gem file, that is file type for Ruby library. So it have a metadata like dependency or author name or version or something. So RAA don't have these mechanisms. And Ruby gems is released for handle .gem file type. So Matt decided to bundle Ruby gems as a default package manager for Ruby languages at Ruby 1.9. So it's a big decision for us. So this is the history of Ruby gems and other related projects. The first version of Ruby gems has been released 24. So this year is a 20th anniversary of Ruby gems. So after that, so Ruby 1.9 is released with a Ruby 1.3. So maybe you don't know, GitHub provides a gem repository for us named gems.github.com in the past. But it closed at 29, so it's 55 years ago. And Gemcat and Ruby Forge are migrated. rubygems.org, we always use it. So in 2013 or 2014, so RAA and RubyForge are completely closed. After that, so we have only rubygems.org for canonical Ruby library repository today. So RubyGems allows the installation of many libraries from the rubygems.org. In today, so we need to know the gem spec for RubyGems. At first, gem spec can be accessed using the gem.loaded-specs method in IRB at any time with your Ruby environment or production environment. For example, the gem spec of rack is provided here as in this example. Oh, sorry, overwrite the interpreted. So including this is including the version or author or description or something. You can inspect them. So how load libraries by RubyGems? So RubyGems extends the original Ruby required for loading libraries with a gem spec. The original Ruby's required can only load from the load paths, However, RubyGems has the ability to automatically add gem paths even though that do not exist in load paths via the extend require. RubyGems has an extend require. Therefore, extended require is slower than original Ruby's require. Why slow down extended require by RubyGems? So this find by path method, our image, has a stubs method that returns all of the gem spec from the Ruby installation path. So extended require by RubyGems will search all of gems, which causes your require to be slower than the original Ruby require. For example, in my local box, I try to load only big decimal like this. It took 0.27 seconds to load, but the plain environment with .-disable gems option is 3,080 times faster. So -disable gems enable to avoid to load Ruby gems automatically. So it's time for bundler. So bundler keep the performance of original Ruby's require. How works that? At first, bundler provides this essential version locking functionality that is additional feature of dependency resolution, which can be achieved by using a gem file. You know this example, at first you need to specify from the source site of gem provider. If you use private gem server like Sidekick Pro or your internal gems built by your company, you should add your gem server with under this source lines. After that, so you can specify gem name and the requirement like a version range. Bundler will generate a log file named gemfile.log as a default like this, right example. Log file has all of dependencies or declared by gem file. In this example, we specify RSS gem with a rect image. So this log file contains RSS and its dependencies, named ReXML like this. And the log file also has a platform, like CPU architecture and OS version. Finally, log file has a version of bundler when log file is generated. Bundler will use them for version locking feature. So Ruby gems don't have version locking feature within a Ruby process because Ruby gems can't handle gem file or log file. So we need to run a concept of dependency resolution before bundler's internal. So it's one of the important parts of modern software. So we will see how bundler selects the gems we need for our application and updates the necessary versions. So let's look at how works PubGraph. That is a resolution engine. Bundler uses PubGraph for their resolution engine since version 2.4. This version allows to run faster than Merino, that is the resolution engine of Ruby gems and the old version of Bundler. Let's take a look at how the PubGraph code actually works. In this simple example, a gem called foo and bar defines the above version dependencies, and the constraints of our requirement are available. So we declared them with a PubGraph static package source and add and root method, like this simple example. In real case, so bundler add all of gem name and versions declared by gem file with metadata of rubygems.org, and their constraint same as this example generated by gem file and log file in your production workspaces. So after that, so we can pass this source definition into an instance of PubGraph version solver class. So finally, we can get a resolution result with calling solve method like this. So we can get this result in this example. So this time, we simply require bar version 1 or higher, and bar also depends on foo 1.0 in this version. So these two versions are selected. So this is a simple example. So second case is here. So in this same list of gems as a before slide, so we specify foo 2.0 or higher with a root method. So it's a new constraint. So we can see a PubGraph will return PubGraph solve failure exception. So this is a failure of the dependency resolution. So what happens? So it's in this example, so it tried to select a foo 2.0 by pubgraph. So, but foo 2.0 depends on the bar 1.0, and bar 1.0 depends on the foo 1.0. So the first condition of foo 2.0 or higher cannot be never selected. So finally, pubgraph will exit with a solve failure exception in these cases. So the third example is here. So this case is a bit of example. A bit of complex. So we have 3 versions of foo and 2 versions of bar and 1 version of buzz in this example. So we have our 6 gem names and versions combinations. So if we request buzz 1.0 from the pubgraph, so it will look for buzz 1.0 and any libraries versions above 1.0 of foo on which buzz depends. So there are 2 versions above foo 2.0 and 3.0. Pubgraph, at first, pubgraph tries foo 2.0 at first. It depends on bar 1.0 and bar 1.0 depends on foo 1.0. So this is the same cases of the second example. So it does not resolve foo 1.0 specified by buzz. So, but in these cases, so bundler tried to next cases. So pubgraph will look at the foo 3.0, and foo 3.0 depends higher version of bar 1.0. So finally, pubgraph choose bar 2.0 and buzz 1.0 and foo 3.0 in these cases. So this is a only small example and part of the pubgraph algorithm. So if you're interested in pubgraph and its algorithm, so please read original developer blog by pubgraph and Ruby implementation of pubgraph. So how use the results of dependency resolution or by pubgraph and bundler? Today, I will introduce part of that. So bundler will clear your load path at first in a Ruby process. After clearing up the load path, bundler invoke specs for method with bundler definition. This method returns the gem spec collection returned with the name and versions from pubgraph and gem file. The returned gem specs in these cases, in our first example, are bundler and reXML and RSS. Finally, bundler setup will invoke bundler RubyGems replace entry point methods. So these methods will revert all of extended methods by RubyGems. After that, the bundler will inject these passes into your load path environment variable like this. So this mechanism enables us to load only latest or selected version of RSS and reXML and bundler with this environment. So under this environment, so Ruby only searches for these 3 passes and Ruby system passes, which result in our fast loading process, because bundler uses the original Ruby require and only searches these passes and Ruby installation passes. So, okay, this is a half time of my slide. Okay, this is our lesson category of RubyGems and Ruby and bundler. After that, so I will talk future plan of RubyGems and Ruby programming languages. Now that you have seen how work RubyGems and bundler, so we also need to run the future of standard library. So I managed the standard library for the Ruby languages in recent 10 years. I will provide an explanation of the default and bundle gems. So I organize the default and bundle gems for the Ruby release packages each year. So I classified 3 categories with standard library. There are standard library and default gems and bundled gems. The canonical repository of standard library is the same as Ruby core repository. The release cycle is also the same area as the Ruby interpreter. The default gems and the bundled gems have somewhat different from the standard libraries. So what's the default gems? Ruby has a unique library known as the default gems, which can be required independently of the gem file and updated through the gem update command or Ruby gems. To require RSS, so we can follow this syntax, then call the default gem question method with a gem loaded specs, for RSS. So it returned false. So RSS is not default gems. So in the other hand, OpenSSL, this case returns are true. So OpenSSL is a default gems. So you can inspect which library is default gems or not in this example. The upstream of default gems are the Ruby repository or under the Ruby organization of GitHub. Most libraries are being developed under the Ruby organization of GitHub. And also release cycle is the same timing as the release of Ruby core package, or it is each maintenance convenience. So IRB or some of libraries are aggressive updated with a new feature or bug fix or something. As shown in our right image, so a lot of repository has been created under the Ruby organization of GitHub. So these repository enable pull request and GitHub actions. So you can develop default gems with a typical GitHub workflow, your workflow. This section explains how default gems developed with Ruby core repositories. So default gems will merge into Ruby core repository automatically. You don't need to care them for the Ruby core repository or merge or something. So we have auto sync feature developed by me and other Ruby committers. In this example, commit of default gems made in Ruby gems and Prism, that is a new generation parser of Ruby languages, merged with the commit message changed to show where they came from. Small string. In Prism, things not related to a Ruby repository, such as a CI configuration or JavaScript or Rust language implementation, are not synchronized in this mechanism. So this means your contribution of default gems merged into the Ruby core repository. So Ruby core packages contains your contribution commit of each year. Ruby also has a bundled gems. So bundled gems are pre-installed gems that are automatically installed during the installation process without requiring any further gem install command. This bundled gems is same as a local installation of gems such as Rails or Sinatra or Rack or something. So I'm working to migrate the Ruby standard library to the bundled gems and default gems. So bundled gems are completely developed on the GitHub, and not RedMine or our canonical repositories. Why we need to default and bundle gems? First reason is security. So the releases of Ruby core is hard work because we need to release multiple branches just at the same time. In this time, so we have Ruby 3.0 to 3.3 and 3.4, that is a development version of next Ruby. The core team can release the default gems and bundled gems independently. So you can update them without Ruby core update. So the left image is vulnerability announcement of RDoc by me. So you can update RDoc. You can update safe version of RDoc from the vulnerability versions without a Ruby core update via the default gems or bundled gems. So second reason is sustainability. So we can involve a new contributor easily for the default gems and the bundled gems. If you are interested in bundled gems like RSS or IRV or net-smtp or something, so you can contribute it now and today via GitHub. In fact, so we have new maintenance of IRV and net-IMAP or other libraries in recent years. So right image is a new release announcement by Stan Lu, who are developed by experienced team of Shopify. So now IRV has a lot of useful features rather than apply or some of gems today. Using default gems and bundle gems and the bundle environments, you need to differences with them. For example, you need to declare RSS with gem DSL if you want to use RSS provided by bundle gems. But OpenSSL case, you don't need to add them because bundle handles default gems for that. This means, so if I change big decimal as bundle gems from the default gems in the next or future version of Ruby, your application will break when upgrading from the Ruby 3.3 to Ruby 3.4 without updating your gem file. I will introduce our notable feature of Ruby 3.3 or related features about the default gems and bundle gems. I understand this frustration like why Ruby break my application when upgrading each version every year? Why Ruby break my application? I added useful feature to take care of this issue with Ruby 3.3 in last year. So if you need to use gems such as CSV, Ruby will issue warning on Ruby 3.3 like left images. These warning can be suppressed by adding CSV into your gem file. First example is here. So bundle inline provides feature to embedded gem file into your Ruby code like this. This means that gem file has no gem dependencies. So when you run this above code, you can see these warnings. These warnings detect Ruby try to mutex M and RS without gem file declaration. And the warning shows what version of Ruby will migrate or migrated this standard library to bundle gems. So I strongly recommend to add these gems into your Ruby file, your gem file, if you got these warnings. Next example here. So this bundle inline has active support. In this case, Ruby warned about the big decimal and others because this version of active support used big decimal without declaration of dependency of gem spec. The latest version of active support has been fixed this warning with this feature. If you got the same warnings in your application, it's good time to report these warnings to gem author. I need your help for migrating bundle gems. So finally, I'll introduce future of standard library and my plan. What happens in Ruby 3.4 or 3.5? So migration over the bundle gems. So this illustrated changes and plans the number of default gems and bundle gems. So I will expand number of bundle gems because we need more contributor and more easily release libraries rather than Ruby core releases. For migrating bundle gems from the default gems, I need to consider some of issues. So our first example is that standard library has dependency across standard libraries. So in example, so JSON has extension feature for OpenStruct. So we need to make this feature is optional from the mandatory like this. Second one is a C extension of bundled gems. So if you want to use big decimal without a build tool chain, so there is no way to that now. So some of people don't have that like Lambda, AWS Lambda, or some of container images. So I can resolve that to provide native extension gems like Nokogiri or SQLite 3 or something. So I try to resolve this issue until Ruby 3.4 final releases. So next one is a cross-compilation problem. So Ruby gems and Bundler didn't have a cross-compilation feature with standard ARM. What's the root case for this? So Ruby gems will install C extension to these directories that are under the extensions and lib and ext directories. So RubyGems 3.4 or later doesn't make clean after building C extensions. So we can see C extension under the ext directory today if you use the latest version of RubyGems. Today, a lot of gems expect to available C extension under the lib directories. This behavior is totally wrong. It easily crashed the cross-compilation platform and to use multiple Ruby versions. We should use extensions directory because this directory have a platform and Ruby versions identifier. It's only safe way to load C extension. I merged to avoid to put the C extension under the lib directory with the configuration in the next version of RubyGems. So if you set this install extension in lib options as a false, so RubyGems will not put the C extension to under the lib directory. I used this feature for a few months. There is no problem with that. In alternative benefit is disk spaces. So we lost our disk space in production environment because RubyGems and Bundler copy same C extension and the library directory. So I try to fix this feature to enable by default in next or future version of RubyGems. So I would like to full support cross-compilation for the WebAssembly or some of the cross-compilation platform. The next one is a separate vendor library with a namespace. So RubyGems and Bundler are enabled to resolve activation issues, which occur when attempted to activate a gem within a RubyGems or Bundler. As a result, gems activated by RubyGems or Bundler cannot be used in your application. Example, so RubyGems and Bundler use some of the default gems that is timeout library in their internal. You may encounter this error message in your Rails application. Because RubyGems or Bundler activates the different version of timeout like 0.3.1, but your Rails application wants to use timeout 0.3.2, so this can't resolve in this RubyGems and Bundler. You need to use only the same version of RubyGems and Bundler. What's the RubyGems approach? So we adopt the vendoring approach. So RubyGems and Bundler already have some of libraries such as a URI and file types like left images. So it's a very hard to maintain for me. So if Ruby core team issues the vulnerability announcement, so I or RubyGems and Bundler team will need to release RubyGems and Bundler in same time. So next approach is rewriting C extension to pure Ruby code. So you can use any version of Cyc that is a lib YAML wrapper. Because RubyGems and Bundler use the original Ruby implementation of YAML serializer like write images. So Taomori-san, who are my friend, will introduce the namespace functionality similar with package feature of Java languages. This feature enables to running multiple C extensions and multiple versions within same Ruby processes. So I'm looking forward to complete his work in this year or future years. Finally, so I will introduce a type system. So final one is a type system for a standard library. Ruby have some of type system like RBS or RBI by Solvet. So RubyGems and bundle will create boilerplate of RBS when you run bundle gem command today. And I and Sotaro-san, who are creator of RBS, will migrate signature files from the RBS gem into our bundle gems. Left one is a production code of prime libraries. Right one is a signature file of prime libraries. So we already provide RBS test framework. So RBS have a simple test framework named RBS test for the gem developers. You can test your signature file with the RBS test and the test unit framework. So we can improve our developer experience with a language server and RBS files in our service. So I'm happy that you're interested to write RBS or RBI files for the Ruby ecosystem with this test framework. Okay, it's time to wrap up. So I will introduce the key knowledge of RubyGems and Bundler and their history. And I also introduced the notable feature of Ruby 3.3 and the future work of standard library, Ruby 3.4 or something. So I appreciate and but for allowing me to my time to develop Ruby and the Ruby ecosystem. And thank you for attending my talk today. Finally, I introduce Matt's comment. So Matt said Ruby is a programmer's best friend. So my goal is to develop a Ruby programming language is best friend by you. Thank you.